This video, I want to do a truth table for a little bit more complicated argument and see if we can get it down. I'm also going to try and take a few shortcuts in here. The thing is, we want to determine, is this argument valid or invalid? But here we've got a lot more work to do because in order to get the premises, so here's premise 1, here's premise 2, here's premise 3, and here's the conclusion, or the supposed conclusion. Is this argument valid is what we want to determine. And in order to do that, we've got to do some parts. Now, what I've done here is when we have a argument that has 3 constituents in it, or 3 letters, the way the field is going to look for the constituents is going to look like this. Again, what this is every situation where all are true, where all would be false, and then every other possibility in the middle is what we want to do here. So make that a little bit clearer there because that should be a false. So basically, if you've got 3 letters, this is the way it should look. Here's every truth combinant where all are true, here's where all are false, and everything in the middle is every other possible combo that you could have. This is the most efficient way to do it. If you've got 3 letters in a problem on quiz 9, make it look like that, period, whatever your letters are, and just be consistent in your application. Then what I like to do is I like to use my tree rules to make this as easy as possible. I want to do the simplest stuff first. So this one I've got not A in the 3rd premise slot. That's the simplest one. There's the least amount of work to do. In order to figure out what would be the truth values of not A, I'm going to look over at A here, whatever I've got here, using the negation table rule. Whatever I've got over there, I got 4 T's, 4 F's. So the values of not A are going to be the opposite of that, period. 3rd premise values are done. Okay? I'm actually going to do the conclusion next. That to me seems to be the next easiest one. I'm going to look at B and C over here, and here I use the constituents as a reference. If you look at the table rule for conjunctions, for a conjunction to be true, both sides have to be true, period. Which makes sense. That's what a conjunction is, where you got to have both parts. So I'm going to look at the values for B and C, and I'm going to get a determination. Yep, that works. And that's going to work, but literally everything else is not. So nope, 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 yep, nope, nope, nope. Conclusion values are done. Now you could copy over every single letter thing and then figure it out that way if you want to do that. I'm trying to do as little as possible. C arrow A. Now this one, to use the letters as a reference, you've got a little bit more work to do because here's the left side, here's the right side. But remember, table rule for arrows, true left, false right. That's the only time an arrow doesn't work. So that would work, that would work, that would work, that would work, that would not. True left, false right. Nope. That would work. True left, false right. That doesn't work. And that would work. That premise is done. Now this one I got a little work to do. XOR. So I'm going to have to figure out this first because it's in the parentheses and then figure this out. I'm going to look at A or B. Now XOR, the only time an XOR is true is when one of the disjuncts is true but not both of them, because that's literally what it means. So what I want to do, if I have all T's or all F's, this thing's not going to work for this. And if I've got 1 T on either side, that's when it's going to work. So I'm going to evaluate this part first in order to get to the inclusive part. So that would not work. That would not work. That would. That's 1 of the T's. 1 T, 1 T, 1 T, nope, and nope. And now what I've got is I have an inclusive disjunction between this thing, for which I have the values, and C. So what I'm going to do is I'm going to look at this or C. Now with inclusive disjunctions, at least one side has to be true. Both of them could be true. So now I'm going to take these columns and evaluate them together. Again, I could take the C stack there and copy it over here, but I'm just going to use this for reference. So that would work. That would not work. That would work. That would work. As long as I see 1 T, I get a T. That would work. That would not. Okay? So now I really don't even care about this column because what this right here, and actually I should have written it over a little bit more, so I'm going to do that real fast. Because these are the values not for C or whatever. And so now I have the values for this premise. If you're like, no, why'd you erase that? You can go back in the video and see what it says. But here are the values for the premises now. So what I want to do, even though it's more complicated than the other ones, it's all filled in now, and now I need to make a determination. I need to see when all the premises are true, is the conclusion also true? So I've got 3 premises here. When these are all T's, do I have a T over there? In every instance. Now, if that's the case, then the argument is valid. If it's not the case, then the argument is invalid. So let's look. Nope, 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 nope. I'm looking for rows where we've got all t's. Here we go, right here. So in this row, I've got, look, true premise, true premise, true premise. And I'm not here, not here. So this is the only row I'm concerned with now. What do I have over here? False. That means this argument is invalid, period. When all the premises are true, the conclusion is false. This argument is invalid. And here's the counterexample. When A is false, when B is true, and when C is false. That's one way of writing it. I can also put it this way. So this is the counterexample. Okay, when A is false, when B is true, and when C is false, this argument doesn't work. So this argument is invalid. Next video, what I'm going to do is going to do the truth tree for the exact same argument. Okay, now again, if it were valid, if you had all t's and you had a t over in the conclusion, assuming that you filled in the table correctly, there's nothing else to do. There's no counterexample for a valid argument. This is how you do a larger truth table.